In this tutorial, we're going to take a look at writing the domain and range for quadratic functions for parabolas, and focusing much more on if you're given a graph, how do you write the domain and range, not so much the equation. I did write the equation for the first one. This is the y equals x squared parabola, but all the other ones are some transformation of that. So domain, first of all, the domain, these arrows means that the graph does keep on going up and to the right forever, and here up and to the left forever. And so the domain is any real number, and that's why I also included the equation here, because the domain is a set of x values you can possibly substitute into the equation if you have it. And you see, I can square any number I want. For example, if I square 2, I get 4. Okay, that's why that point's in the graph. That's the point 2 comma 4. 3 9's on the graph, so that's the point 3 9. X could be 4, and then we'd be up here at 16, a little bit off the top of the graph. I can square any number I want and get some y value. So, and it could be decimals. For example, you know, x could be 1.2 here, and if I square that, I'll get some y value here. For example, let me show you here. 1.2 squared is 1.44. So 1.2 is approximately here, so that point right there would be about 1.2 comma 1.44. So you can have x values that are decimals. Now the range starts out the same way. It's y. The range is a set of possible y values for the function, and it's y is a member of the set of real numbers. That this funny capital R stands for real numbers, such that, and there's always a restriction on the domain for any upward or downward opening parabolas. And if you look at the parabola here, you see this one has a lowest point, a minimum point, and the y value is 0 right there. As soon as we go to the right, y becomes bigger. For example, it's 1 here. It's, you know, maybe 1.7 or 6, something like that here, and it does keep on going higher. And the same thing to the left. Y is a positive value over here. So the way we write that restriction is y, the set of y values is always greater than or equal to 0. 0 being the only place where y is 0 is right at this minimum point. Now the way we say that is, and this little Greek letter is a symbol for is a member of. So this first part we say y is a member of the set of real numbers. That's this part right here. That vertical line is an abbreviation for the two words such that, and this says that y is greater than or equal to 0. So that's how you read that whole line. Y is a member of the set of real numbers such that y is greater than or equal to 0. Now, just a little bit more about the domain and range, why they're real numbers. There's two parts to this. In the original graph here, if I back up a little bit, see I went out negative 10 on that side to positive 10 here, and actually you can't really see where x is 10 or negative 10 up here because it's off the top of the graph or the page. So I made a sketch using Desmos of this function, and notice my x-axis goes out to 1,000, well past 1,000 here, and past negative 1,000 to the left. So for example, x here is 400. 400 squared is 160,000 from that equation, y equals x squared. So x can be some arbitrary large number like 400. You know, notice here that y is 160,000, and it keeps on going up. So x is allowed to be a any large number, positive or negative, and actually y can also be any large positive number too. It goes upward without bound. Now let's get rid of that. Now the real number thing. If I only had the restriction that x had to be just integer numbers, okay, it couldn't be decimals, fractions, fractions between some whole number. You see, that's what it would look like. We wouldn't be including these points in between. So for example, you know, x is probably about 0.5 there. So we wouldn't be allowed to use those points in between here if x could only be integer numbers. Okay, so if we're only using integers, it would just be discrete points we would just jump from. We wouldn't be including the points in between here. Another one in B here. Again, the domain is the entire set of real numbers. These arrows mean it does keep on going down to the right and down to the left. So x can again be any real number whatsoever. The range for this again starts the same way y is a member of the set of real numbers such that, and the restriction here, you see this is a maximum point, the y value there would be 4. And so we say that y is a member of the set of real numbers such that y is less than or equal to 4. 4 is the highest y value, and as soon as we go to the left or the right, y becomes some smaller number. You know, maybe y is about 3.5 there, it's 3 there, and of course it can be negative 2 down here or down here. So that's the range for this, the second one. In C, and the parabola can be wider opening. This, you might think of this as being vertically compressed compared to the first one, or horizontally stretched, I suppose. But the domain is still the entire set of real numbers. It does keep on going forever out this way. I would see points up here somewhere and the same to the left. So x can be any real number whatsoever. And the range again starts the same way. Y is a member of the set of real numbers. The restriction here is, see, the vertex has a y value of -3. That would be -3 on the y-axis. So y is greater than or equal to. See, y is -3 here. As soon as we go to the right, y becomes a larger than -3 number. For example, it's -1 there. It's, you know, maybe 0.9 there or something like that. So that's the lowest possible y value on the entire parabola. One last example. Here's a really vertically stretched one. It's a very skinny looking parabola, but again, the arrows means it does keep on going down to the left and down to the right. So the domain is still the entire set of real numbers. And the range starts the same way, but this has a maximum value. See, y would be 1 right here. And then as soon as we go to the left or the right, y becomes smaller than 1. So y is less than or equal to 1 would be the restriction on the range. And that's the end of the tutorial.